Hi everyone, welcome back to my channel and Happy New Year. In today's video we are doing anti-differentiation. And as you can see from this really long word, you can recognize that we have the word differentiation. And that's what we learned earlier. We had a video on introduction to differentiation where we basically find the derivative. So let's say I have a function f of x. And if I derive it, I get f prime of x. And that process is called differentiation. Differentiation. But now instead of differentiation, we have the word anti in front of it. And you guessed it right. It's the reverse process. So rather than deriving it, we're now going back and we want to find the original function. So this is called anti-differentiation. And this is also called integration, and they both mean basically the same thing. So before you were given an original function and you want to find the derivative, now you're given the derivative and you want to find the original function. So we have, let's say, if f prime of x equals to f of x, then the integration of f of x would be capital letter f of x plus c. Now this may be confusing because there's a lot of terms here. Basically, this symbol here means integration symbol. It's basically whenever you see this symbol, it means you want to find the original function. And the most important here is the value c here. So let's say I want to find the integration of 2x. So basically what this means here is I'm given 2x is the derivative. Now I want to find the original function. And what would that be? That would be x squared, right? Because if I derive x squared, I get 2x. Very simple. So now let's just go back a bit and try to find the derivative of certain functions. So let's just say I want to find if y equals to x squared plus 3. I want to find the derivative, right? That would be what? 2x, right? And this 3 disappears because it's a constant. Again, I want to try to find the derivative of x squared plus, let's say, another number, plus 5. The derivative would still be 2x. Let's say I want to find the derivative of 2x minus 100. The derivative would, you guessed it right, would still remain the same, 2x. And so what pattern do you see here? You can see that whenever we have a constant, that constant disappears when you derive. So that means that, let's say this is the original function. Let's go back to this process here. We want to find the integration of 2x. Basically, we want to find the original function. We always must add plus c because we don't know what that number is. And when we derive it, we get 2x. But we don't know, there may be an unknown value here that is eliminated when we derive. So we must always plus c. That's the most important thing. So remember to always do that when you do integration. So now let's try finding the integration of some problems. Now in anti-differentiation, just like differentiation, there is a formula. But the first question, let's try doing this without the formula so that we can try thinking it ourselves. So we have 2x cubed plus 3x squared, and what we want to do is find the original function. So this here is the derivative. We want to find the original function. So just like, for example, y equals to x squared, when we derive, we get y equals to 2x, right? And what happens to the power is that from 2 now it becomes 1. It's subtracted by 1. So the reverse means that then it probably, instead of subtracting 1, it will add 1. So the power will be 4, right? And when we derive, we want to have 2. So how do we do that? Well, we know that when we derive, it's always going to be 4 times something. And we know that 4 times something is going to be 2. So 4 times what equals to 2? Well, 4 times 1/2, right? So now let's do this, 3x squared. Again, you can see that the power increases by 1. So it's going to be x cubed, because if we derive, that becomes 2. And again, we know that a number times 3 is going to be 3. So what times 3 equals to 3? Well, just 1, right? So it's going to be just x cubed. And again, we must always add plus c, just like what we said here, because if we differentiate, let's say if we derive this plus 5, that is gone. So we're going to plus c because we don't know what that constant is. So whenever you do these questions, since you're new to it and you're not sure, you can always try to check it by finding the derivative. So if we find the derivative, it should be the same as this. So let's try. Well, if I want to find the derivative, remember it's 1/2 times the power. So 1/2 times 4, you become 2. And the power subtracts by 1. So 4 becomes 3. And here, this 3 moves to the front. So it's going to be 3x. And that power subtracts by 1. It's going to be x squared. And if you take a look, that's exactly the same. So we know that we got it right. So now let's take a look at x to the power of n. So now I'm going to introduce the formula to you. So if you take a look at the pattern of what we did was the power increases by 1. So we have n. That means that the new power, the original function, will be n plus 1, right? And the value in front, we can see that, well, here it's 1/2, right? And what we're trying to do is 1 over a value times this is going to become 2. So it's going to be, if we take a look at the pattern, it's going to be 1 over the same power, n plus 1. And again, plus c, because whenever you integrate, always plus c. So now let's try to find the derivative, find the original function of square root of x. So let's just rewrite this in terms of power. We know that square root is the same as x to the power of 1/2. So let's do that, and we want to find the integration. And let's try making use of this formula here. So we have 1/2 as n, so the power becomes 1/2 plus 1. And 1/2 plus 1 is 3/2. And it's always going to be 1 over that power. So it's going to be 1 over 3/2 plus c. So let's simplify it. Whenever you have 1 over a fraction, that fraction flips. So it becomes 2/3 times x to the power of 3/2 plus c. Now let's try to do negative sine x. Now this is trigonometry and it may be confusing, but so let's take a look at this rule here. Whenever we derive, it's gonna be when you have derivative of sine x, it's gonna be cosine x. Finding the derivative of cosine x, you get negative sine x. The derivative of tan x is secant squared x. Now there is a way you can do this without a formula, but for now, try to just memorize this. So we are given negative sine x as the derivative, and we want to find the original function. So because this is a derivative, let's take a look at the derivatives. So which of these is the same as negative sine x? Here, right? And what is the original function? Well, it's cosine x. So our answer will be cosine x plus c. Simple. And now we have secant squared x as our derivative. So if we take a look at our derivatives, we have secant squared x, and the original function is tan x. So our answer will then be tan x plus c. And that's it for our video. Thank you for watching, and any advice I would give for those of you who are new to this idea of anti-differentiation is basically just practice, because it really helps when you practice, you start to get the hang of it. Really, it's quite straightforward. It's just the reverse of differentiation. And again, thank you for watching, and I'll see you guys next time. Bye-bye.